Hi, I'm Anthony. I'm a program manager at Meta. Today, I'll be showing a simple example of how machine learning can be applied to a real-world problem. Using the example of predicting a power plant's output, I'll be covering 1. Selecting a model approach, 2. Separating data into training and validation sets, 3. Building the models, and then finally, evaluating the model performance based on the output metrics. Our first step is understanding the problem. Given the problem is predicting energy output given historical data, this is an example of supervised learning where the models provide features and outputs. Within supervised learning, because we want to estimate a continuous value rather than a classification, I can use regression models. It also becomes very easy to interpret the model if we use a single variable. I found this research study concluding that temperature was the largest driver of power output. So let's use that as our simplest model. But I'd also like to compare this against a more complex regression using all the features provided. For the next step of preparing our data, I'll be using a 70-30 split. We have 70% of our records in the training set to build our models, and the remaining 30% will be part of the validation set to compare the model's performance. I did this manually in Excel. Next, we'll build the models. Today, I'm using Excel to run regression. In the first model, I'm using a simple linear regression using only ambient temperature as the input feature. After running this on the training data, we take a look at our coefficients. Ambient temperature has a coefficient of -2.17, and the bias term is going to be 496.98. Visualize, the model looks a little something like this. Similarly, I'll run a multiple linear regression model using all the features provided. After building the model with our training data, we get the following equation for our power output formula. Negative 1.98 times our ambient temperature, negative 0.23 for exhaust vacuum, 0.06 for pressure, negative 0.1 for relative humidity, and our bias term is going to be 456.77. We're now going to run both models on our validation set. Remember, this is data that's used to evaluate how well a model can predict given new data sets. With the two models built, I will now evaluate which one has a better performance. I'll be using MSE, or mean squared error. This will be adding penalties for larger prediction errors. Overall, we can see that multiple linear regression model has a lower MSE value compared to just using temperature alone. So this is our best model. Again, I'm Anthony Ewan. Thank you for watching, and please share feedback on this approach to machine learning.